Howdy, Internet students. Mr. Hermson here. Today we're going to work on Objective 1.61a. If you need to do a retake, here's the extra practice. I'll go through a couple of these problems, and then you can finish this practice and go ahead and take your retake then. So this is all about square roots here, being irrational numbers at times. So we have to figure out if each of these numbers is either rational or irrational. Remember that irrational numbers are, as a decimal, are numbers like pi. I'll just write that, where the decimal goes on forever and ever without repeating. And then rational numbers are numbers that either repeat or end as decimals. Also, if you can write a number as a fraction where a and b are both integers or whole numbers, so if it's a fraction, if it can be written as a fraction, then it's a rational number. So to check to see if this is a rational number, let's go ahead and do the square root of 335 on our calculator. And then look at the decimal, and if we see that it looks like pi, where this number doesn't seem to have a pattern. It starts with kind of a pattern, but then it keeps going on with no real pattern. So we're going to say that this is an irrational number. We're pretty sure it's an irrational number. So it equals 18.3030522. I think that would keep going, and the numbers are random. So that is an irrational number. All right, let's take a look at B and check that out, see what that looks like, the square root of 289. That equals 17. And since that is a decimal that ends, that's a rational number. In fact, it'd be pretty easy to write a fraction out of that. And remember, any number that you can write as a fraction using integers or whole numbers, that is definitely a rational number. All right, let's move on down to number 2. It says label each as rational or irrational again. If it is a rational number, write it as a ratio of 2 integers. I'll show you how you can use your calculator to do that. If it is irrational, explain how you know. Okay, I'm going to pick 2 of these, one that I think is rational and one that's irrational. I'm going to do B here. I know that since this is a repeating decimal, that this is a rational number. Okay, if it repeats in a pattern, it's rational. And this number right here, if you don't recognize it, you'll notice that the ... at the end means it goes on continuously, and there really is no pattern to the numbers. That would be an irrational number. Now, part of what we had to do was, if it was rational, we want to write it as the ratio of 2 integers. So 2.6 repeating, I'm going to do that. I'm actually going to trick my calculator into doing that for me. If I put 2.66666, and I'll just go all the way to the end of the screen, then I'm going to press math, and number 1 there, press enter, turn it into a fraction. If you put enough 6's in there, it will find that and write it as a common fraction for you. So the fraction that's the same as that is 8/3. Some of you probably knew that 0.6 repeating is the same as 2/3, so 2 2/3 is 8/3. All right, let's go down to number 3 here. Label each expression as rational or irrational. All right, I'll do, the first one says the square root of 8 times the square root of 18. So let's do that on our calculator. Square root of 8. Then I have to press the right arrow to get out of that, but I'm going to multiply that by the square root of 18. And we can see that that equals 12. And 12 Since that's a decimal that ends, that would be a rational number. Okay. The second one in that set is the square root of 8 plus the square root of 17. If I do that, square root of 8, I'm going to press the right arrow again, plus the square root of 17. That looks like I'm not seeing any pattern there. It doesn't end. I think that's an irrational number because I'm seeing a never-ending and no pattern decimal. Okay? All right, let's go down to number 4. It says write each rational number in the last set as the ratio of 2 integers. So any of these that are rational, like A up here, we want to write that as a ratio of 2 integers. If it's a whole number, it's pretty easy. We just do 12 over 1. But basically, you're just going to turn that into a fraction. All right, that's the end of this video. Good luck on the retake, and we'll see you soon.